Hi, welcome to an Arduino tutorial from Robojax. In this video I'm going to show you how we can modify and use this 20 ampere pulse width modulation speed controller that can control the motor speed with the knob. We can use it with Arduino to control the speed of motor either by the knob or by sending a command directly from Arduino from a sensor or from other means. And this is now 50. You can get the code for this by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. I've reviewed this module. The link for the video is below. I've explained all the components and included the datasheet and how it functions, and I've tested it, so you can see that from the link below. But here we're going to just use it for this purpose. How this module works is that we have a timer, 555 timer, and it generates pulse width modulation from a potentiometer or variable resistor that is connected to one of the pins. And the output from this chip is biased or connected through some resistors to a gate of the MOSFET that can control the speed of motor. Now, if we cut the path of the signal that is exiting from this chip to that MOSFET, and we connect our own wire and feed the pulse width modulation from the Arduino, then we will be easily using this module without all those wiring and controlling and so many other things that are available as ordinary motor controller for Arduino. It will be very easy to use. You just need to connect the power, your motor, and then two wires. One will be for ground and the other wire is for pulse width modulation signal, which will be connected to Arduino. Let me show you now. I'm not going through those to explain everything. We're just going directly to see how we can modify it, and I will show you those points that we need to modify. But before that, this is how it is connected. I've connected the power here. The two pins are connected to the motor. The polarity for this depends on your motor, whichever direction that you want to rotate it. And now if I rotate this, can control motor only in one direction. And here is a module on eBay. Many people are selling this under different labels and name, but they name it usually 20 ampere 10 to 60 volts pulse width modulation. It's sold around $375 US on eBay, which will take about 60 days to get it. You can get it also from Amazon very quickly with a little expensive, maybe $10–15, but you can get it in 2 days or same day or next day. This is the main timer, the NE or LM555. It's called 555 timer. This is a schematic diagram, but if you have a look at the block diagram, the pin 3 is the output. The pins start from left side 1, 2, 3 up to 8. So we are looking at this pin 3, which outputs pulse width modulation, and we will cut this point that will not allow the signal to come from the pulse width modulation of this chip, and rather we will connect our Arduino at this point, so it will be injected to the circuit. The output stage of this module is based on two MOSFET of 80NF70. This is 98 ampere. It's huge, and they put two of them in parallel, meaning if you have proper heatsink, you can go almost 190 ampere or 200 ampere. So the signal comes to the gate of this, and there are some biasing resistors. We are not going to touch it, and we will just inject the signal at this point. This is the IC555, and these are the two MOSFET output stage. And here is a dot here. From this point, from this notch, we know that this is pin 1, 2, 3, 4, 5, 6, 7, 8, and pin 3 is the output. This pin 3, if we look from the other side, this is pin 1, 2, 3. Pin 3 comes here, and we have one resistor to this point, and it comes here, another resistor. And we have two exact same resistors here. And the first one goes here to the gate of this MOSFET, and the second goes from here to the gate of this MOSFET. So one MOSFET, two MOSFETs are these MOSFETs that are connected in parallel. except the gates are not parallel. The drain and source are connected together, but the gates are biased separately. So we are going to connect our wire. We're going to cut this point, this PCB, and connect our wire in here. We could also connect it on this side. I will see which side is easy. And here I'm using a sharp knife and cutting this point. I just cut one and a little more, making sure it is disconnected. And as you can see, I just chipped this piece of PCB here off. Now I'm using the continuity tester from my multimeter. So if it is short circuit, it will make buzz. Let's check it. As you can see, it doesn't make buzz, and these two lines that are connected, it makes buzz. So I've cut it successfully. Now I'm going to solder a wire here that we will inject the signal, and then one wire to the negative. This is my power supply, and these are my power supply. This is the negative for the ground. Let's see, this is the ground, so I can solder a wire somewhere here. And here I've soldered the wire here because this was more reliable, as the pin of this resistor is also soldered here. And for the negative, I've connected it, soldered it at this point. This is the ground or negative of the module, and I have the two pins here. So the red is pulse width modulation, this is the ground. Disconnect this because this is not being used. Now for the wiring, the pulse width modulation pin that injects to this module is connected to pin 5 of Arduino. The ground of this is connected to the ground at this point of Arduino, and the 2 pin for the power, positive is connected to my battery or power, and this is to the negative of the battery. And here is my motor. And here I have this potentiometer. I could use also this one if you want to connect in here, and it can be inserted, but I'm using this one. We have 3 pins. The right pin, I'm connecting it to 5 volts. The reason for that is when you rotate to the right, it must go to 5 volts, so it can give maximum voltage to the analog input, so it can give you the maximum RPM. So I'm connecting this to 5 volts of Arduino. And then the middle must be connected to this analog. If you make mistake and the middle is connected to 5 volts or to the ground, you will burn this or make a short circuit, either if you rotate it to the left or to the right. So the last one is connected to the ground. Now let me explain the code. Here I have defined pulse width modulation pin, pin 5. You can change it to any other pin that you wish, as long as you connect it to those pins that has this tilde. That tilde in front of 3, that is pulse width modulation. 5 is, 6 is, as you can see, 9, 10 and 11. The rest, they don't have that tilde. So pin 7 is not pulse width modulation, 8 is not, and 2 is not. So you can choose any of those pulse width modulation pins. Then for analog pin to read, if you are using potentiometer, analog 0 has been defined here. You can choose any other analog pin that you wish. So these 2 pins are used, and then inside the setup, using pin mode, we define that pulse width modulation pin as an output, and also we initialize a serial monitor so we can display the value on the screen. And then using analog read, we read the control pin that is, and the value for this, the result is stored here. We call it pot value or potentiometer value of type integer. So this variable will be used throughout the code. Then using the map, we map the value that we get from potentiometer, which is from 0 to 1023. So this is the beginning, that's the end, the maximum, and we map it to the two value of 0 to 255, meaning if it is 0, the input is 0, the output would be 0. If the input is 1023, it will be 255, and any other number in between will be proportionally distributed using this calculation. So this will do the calculation for us and will give us a value between 0 to 255, and it will be stored in the variable called pulse width modulation PWM of type integer. This has been commented out. I will explain it next, but this will come here, and we use analog write. We pass this pulse width modulation pin, pulse width modulation here to this pin. Pin 5 will have pulse width modulation, and the motor will start rotating according to the value that is here. And then we also use this serial print. This is a text because it has double quotation, and this is the value that we have here will be displayed here. And we give it 500 milliseconds, and the loop will continuously monitor the potentiometer and send the signal to this pin. Now, because in many applications you might not use the potentiometer, you might use some functions of Arduino or a command based on some other value, you could use it here, and I made it very simple. I've written this function called 2 pulse width modulation, which is below. I will explain it. And here you enter your value as percent, not 0 to 255. For example, you won't know 80 is what speed in this term, but if you put percent, this 80, you know 80% of the speed. So you just enter your value between 0 to 100. So 0 means 0%, 50 means 50%, and 100 means 100% pulse width modulation. And we'll pass to this function, which is in here. When that 80, for example, comes, it becomes V, and we use map and get the V, which is between 0 to 100, so 100%, and it will convert it for us between 0 to 255, and it will return this value. So this will become a value between 0 to 255, which we store it to pulse width modulation. If we uncomment this, which means if this was a comment, and if you have uncommented, then these two lines will be useless, and Arduino will get command from this value and run the motor. Now let me uncomment this, comment this back, and upload the code. Now I've uncommented this portion, and I've added one more thing, that this pulse width modulation that goes to the pin, we print pulse width modulation text with a value, and we also see it as a percent. Here it says arrays, and then this gets the pulse width modulation that you are sending to the pin. It gets it, and it goes to this function, and job of this function is to convert it from 0 to 55, convert it to 0 to 100. So this will also print for us a percent, and also we print this text as a percent. Now let me test it. I've connected this voltmeter to the input, so you can see the input voltage, which is around 12 volts. Let me open the serial monitor. As you can see, this is now at 0%, and in terms of pulse width modulation, the value is 0. In terms of percent, it is 0. So if I rotate this, you see it's between 7 and 8. 3% does not make the motor to rotate. Let me increase it. So if I go 13, it will be 5%. So 5%, this motor will start rotate, receiving pulse width modulation. Now let me increase it. That is 27%. Almost 50, it's 50% now. 100%. And if you pay attention, you will see that 255 was corresponding to 100%. Now let me uncomment this. When I uncomment it, it means these two lines are now useless, and we are getting the signal from here. Code is loaded. The motor is not rotating. I will remove this because this is now useless. Let's go for 10%. So I'm loading the screen. Okay, I disconnected it. As you can see, we are getting 9 instead of 10. It is due to the value that is between between let's say 25 and 26 will make 10%. That's why we are getting 9. That's fine. Let's go to 50. Now I disconnected it and this is now 50. And I disconnected it now. Let's go to 80. Upload it. And connect this to pin 5. So every time I open the serial monitor, it resets Arduino, so keep that in mind. And 204 is 80%. When I entered 80%, it sends 204 to the module. Now I'm sending 100%, and I'm opening serial monitor. The wire is not connected, so it's 100%. And this module can work up to 60 volts, so I can increase the voltage here. You see, now I turned it to 30 volts. But this motor cannot handle it, so I momentarily connect it and then disconnect it. What you can do is, if let's say you have a temperature, if temperature is a variable, let's say TMP, and if the temperature is bigger than 68.3 degrees, and you want to control the motor with 100% or some value, let's say 60%, so this will happen only if the temperature is above 68 degrees, 68.3 degrees. So you can do that. Or you can also make the rotation of the motor function of temperature. Meaning if the temperature increases, the motor should increase. Let's say this is a liquid pump or a cooling fan, so if the temperature increases, this should rotate faster, so the system can get cooler faster. When it goes less than that, the rotation also should be reduced because we don't need it. So this can be also function of that. I think I should create a separate video for that because people have asked for that. I would like to sincerely thank the following people who have supported me via Patreon. Thank you for watching. This was how to modify and use this pulse width modulation module with Arduino. If you learned something and found this useful, please thumb up, as this will help my video in the search result. If you have comment or question, post it at the comment section below. I try always to answer and reply. And if you want to get updates of my upcoming videos, you may subscribe now.